Hi, Gen AI transforming manufacturing from engineering to operations. Hi, I'm Rajan, host. Welcome to the podcast. Today we have Vijay Kumar Ramalingam, Vice President of TVS Electronics, a leader with deep expertise in digital transformation, generative AI for engineering, and the product development. Vijay Kumar has held leadership positions at Honeywell and Bosch, two of the world's most innovative manufacturing companies. He brings unique insights into how AI is transforming product development, manufacturing operations, and India's opportunity in the global electronic manufacturing and services called EMS and the semiconductor sectors. Vijay Kumar, welcome.
Thank you, Satya.
So, right from profiles and the data that I've collected about you, it's going to be very interesting. And I wanted to take a worldly view, of course, towards the later end. But we would start with your journey across the three giant companies that you have worked. So, you have had the opportunity to lead at the three major global companies, which is Bosch, Honeywell, and now TVS Electronics. What's the common thread that connects these three experiences and what drew you to the current company at this particular moment?
Yeah, thanks, Satya. If I look at all three companies, they are leaders in their domains, be it automotive, aerospace, or industrial automation, or consumer electronics, specifically in the transaction solutions in TVS Electronics. If I look at what connects them, is a shared commitment to the customer success, driven by technology and also innovation, with a strong focus on people. Today, technology is evolving very fast, and keeping pace is no longer optional, be it companies or for engineers. Okay, so constant learning, upgrading ourselves, okay, is a very important learning what I have throughout this career. I've come across different transitions. One is from ICE to electric vehicle or fuel cells, even electrifications in aero engines, or if we look at retail, video analytics or AI-based solution, and of course using AI ML for day-to-day activity and engineering, the core product engineering. So these are all fascinating for me. In TVS Electronic, we focus on designing and building the reliable computing and transaction device in India, for India, make in India. By doing so, we try to solve India's specific challenges and reduce our dependence on imports and also, of course, trade deficit, whatever we have. So we want to become a technology backbone that powers every Indian or every company in India for day-to-day transactions across various industries, not just retail, even manufacturing and logistics, banking and government, and also BFSI.
Good to know the commonality across these three companies, putting customers and people at the center and being technologically in a fast-paced environment. I think that catches with most of the wave that we are riding through with whatever is happening around the AI as well as the industry by itself. Good to know that. Now we'll slightly get on to the semantics of the product development, particularly how Gen AI is transforming the product development. I know you are deeply focused on generative AI for engineering and product development specifically. This is what we call as a frontier area, right? Can you paint a picture of how Gen AI is fundamentally changing how products are designed and developed?
Yeah, very good question. If I look at any product going forward, it's going to have all three disciplines: mechanical, electronics, and software. If I look at last few years or 2 to 3 years, software development is accelerating with AI capabilities, be it GitHub Copilot or ChatGPT. Okay, engineering is not far behind. They are also adopting it quickly. Few examples I can quote: generative design in engineering. We try to generate and optimize product concepts quickly for a given set of constraints and boundary conditions in a given design space. Simple example, if I want to optimize a product, maybe the bracket, simple bracket. Okay, so for a given set of load and assembly conditions, I can optimize it for a cost, even the different manufacturing aspects. It may be additive manufacturing, or it can be sheet metal, or it can be castings, and more importantly, the cost. So I can put all these constraints. With that, I can optimize the design not only for the functional and performance, even for cost. So this reduces the complete development cycle, specifically on the concept stage. Okay, so we can able to reduce the time to market quickly. This is one simple example I can go. Second is with AI. Okay, so typically any product will go for finally the end customers. They give a lot of feedback, issues, support, so which can be easily understood, summarized, and we can also get the insights for the product development, okay, on a real time basis. So this is what we are aiming. Of course, we are in the process of developing it, but already at least we get insights from the service ticket. Not only that, if I talk on other aspect of product engineering, the value engineering, okay, so mainly focusing on cost reduction. When I talk about value engineering, of course, it has many features. I talk about cost reduction. There are a lot of data, okay, to get into the value engineering, be it inventory or different vendors available in different locations, and our own sales projections, and also life cycle of the components. When we talk about electronic components, each one have different life cycles. Something will become obsolete in maybe 1 year time. We cannot use that in our value engineering new product, right? And also the PCB design itself. Probably we might have designed this PCB 5 years before. Okay, how can we optimize the PCB design without affecting the performance and also other aspects, PASI, EMI, EMC issues? Okay, without that, how can we able to do that? More importantly, all this product will get into certifications and also rigorous reliability testing. So it has to meet. So how can I do it everything in a certain time frame? Typically, value engineering, if you take any organization, okay, it takes 3 to 6 months time. Okay, and even to collect the data itself takes long time because these are all in a different systems. Okay, it can be structured data. So gathering the data and getting the insight, bringing all of them together, and also as a team, innovate, ideate, okay, come with a solution, even that solution to be validated quickly. So we can use generative AI for this kind of aspects. So this will reduce our time to market even in the value engineering perspective. So value engineering not only in the new design, we can also apply it value engineering perspective.
That's very interesting point of view, not just the concept phase where you come up with different design iterations, but also something that is made a while back and how much it is applicable to now the current conditions and then quickly ramping up. That's a very favorable place of AI, and good to know that you're already on that journey. Now going a little bit further, right from the concept design to simulation, AI, and the prototyping aspects of the engineering and development. Simulation and virtual prototyping have always been important in the product development, right? How is Gen AI changing this particular landscape of simulation and virtual prototyping? Are we moving towards a world where physical prototypes become optional, or still they have a place, the quantity differs? How is that according to you?
Yeah, of course. That's a very interesting topic, close to my heart also. The simulation, virtual simulation, play a very important role in reduce cycle time of any product development. Already, automotive and aerospace companies are master to it. Okay, they reduced drastically launch of products. Even in automotive, so it has come down to 2 years. Aerospace 4 to 5 years. So these are all possible with virtual simulation only. For example, crash test. If we physically do it, okay, we need to have a complete vehicle built in with all the accessories, all the subsystems available, and also expensive setup and time. In case we do see some failure, we have to go back to the drawing board and redesign everything. It takes a lot of time. Okay, but simulation brought inexpensive way of validating the design right in the product design itself. However, this design validation requires numerical simulation that demands very high computing power. We call it as HPC. Okay, so clusters, high performance clusters. Okay, so we have to run it. Okay, so this takes again a lot of time, not like physical testing. Okay, so it requires time, be it non-linear simulation or transient simulations or crash simulations. We have to run for weeks. Okay, so this takes time, and sometimes we may get into convergence issues. Then again, we have to modify the our mesh strategy and come back. Okay, so it takes time. So with AML, okay, so we can able to bring down this cycle as well. Okay, ML can understand the behavior of the product based on the past simulations and physics, complex physics, and it can predict. Okay, so what will be the simulation result based on my new design factors in a fraction of a second, I would say. There are companies mastered in this. Okay, so it's evolving, of course, but it's a good start. We can able to see it's happening. This will reduce our time to market and also avoid respin. Okay, so this is something like first time right. We can able to do that. One example I can quote is, the battery energy storage system, okay, which is a modular or it can be massive structures, something like 40 feet containers or 20 feet containers. So here the cooling and structural rigidity, okay, so optimizing these structures or complete product, it takes long time. And also we need to make a physical prototype that is again expensive, it takes time, but we can able to solve this problem, optimize the cooling and structural rigidity, okay, structural stiffness within a week time, and we can come with a good solution. So this is one of the example I can quote from AI perspective. And AI also not only just do the simulations, it can automate the simulation workflows, repeated workflows. Okay, so even designers can able to do the simulations. Okay, so without getting into the parameters of simulation, okay, simulation solvers. Okay, so these are the additional examples for us, okay, to move towards. And the other thing is simulation provide a lot of data. Okay, so voluminous of data output. Okay, so it can give it at a node level or at a element level. Somebody has to post process and understand, okay, whether the component or the product is going to fail. Okay, it takes time. Sometimes it may happen that we may miss some of the critical thing by human oversight. Okay, AML can bring this kind of insights for the designers to take a decision. So this is going to be something like a co-pilot, I would say, to work with simulation or designers going forward. This will help to accelerate the design. And of course, your question on whether it is going to replace the physical prototype, no. Still, we need to have at least one physical prototype for compliance perspective. Other than that, we can eliminate everything. So it's already happening, and we are maturing in the simulation tools landscape.
It's very interesting on the car crash and other real world examples that you have talked, and particularly the shift left of the tools that were once upon in the arena of simulation getting shifted left to the designers is another thing that we are uncovering as we are going through the discussion with you. So good to know that that is happening on the other side of the world as well. Now, this is on slightly moving away from the technology and then the self-reliance and the use cases around specific functions. I just wanted to take a little more a 10,000 feet view on some of the digital transformation which are enabling these sets of use cases in each and every company. And I know you have led digital transformation initiatives at multiple companies that you have worked. What are the biggest lessons you have learned about what makes transformation succeed or fail? Of course, we know how a tool implementation by itself requires a lot of change management. In the context of a digital transformation, the change management is a huge part of it. But what do you see are the gaps between the plan and the reality? And what have you learned when making those transformations succeed or use cases where you have failed?
Yeah, very good question and interesting also. Digital transformation, of course, it is not a one-time project. It's a journey. Okay, we have to run through it. For which, like any other project or program, we need to have a clear vision and the top management commitment and consistent communication with measurable success factors. Even small success, okay, we have to celebrate in this digital transformation. Other important thing what I had seen is, okay, few things, okay, I would we want to bring a lean transformation in the engineering. It is not only for manufacturing, but even for the engineering. In that case, people are hesitant. Okay, so is it going to reduce the number of people working on the project? With this kind of questions, okay, in their mind. Of course, they will not talk inside, but still it is there in their mind. So we have to bring the confidence that we bring this initiative to make it open and also as a learning journey for them to understand, okay, kind of non-value added item we can automate and they can focus on value added item, and in the journey they can also learn new topics, get a competence, new skills. We can also understand their objective. What do they want to be next 5 years? Okay, accordingly we can plan their training program and also put them on the projects, on the job training. So these kind of things we can always plan. Okay, it is not just reducing the number of people. So we have to train them first, and also we have to bring the confidence, instill the confidence that okay, it is for the business outcome and also it benefit for me. Okay, so we have to bring win-win kind of situation for both companies and people. Once they are clear, of course, they are willing to spend time over and above their regular work. So that is how we looked at when we do a VSM, value stream mapping of our engineering itself. We found a lot of existing process are non-value added. Is it possible to optimize? Yes, we can. So with that, we can re-engineer the process and reduce the overhead or even the decision-making process. So with that, we can able to bring people's happiness and also, of course, business success in this journey. But on the other hand, when we talk about digital transformation, data is the backbone. But now, if you look at any organization for that matter, data is residing in different systems and silos, not connected, and maybe in a different geographical locations also and different disciplines. If you look at engineering, mechanical engineering uses different systems, and electronics and electrical they use different systems and also software. So just in engineering itself, then you talk about ERP, CRMs, and there will be a different data lake. So all these things, how can we bring them together and also make sure that the data are clean and usable? So that's another thing. Based on that, as a leader, people can take a decision. It is not only for the leader, even for others also. Okay, even from the engineer level or even from the supply chain management perspective, they can always look at what is happening. So should I order now? Okay, just in time, though we call it as concept. Okay, we can bring this kind of initiatives quickly integrating with all the systems.
Good.
Yeah, so it is not only this, of course, now security, data security, and also the complaints also coming in. We have to keep this in mind when we are bringing any digital transformation. It is not just some new technology is coming in, I want to implement and see. So we have to go step by step as a journey.
Sure. That was very comprehensive from the value stream mapping to getting the team ready for absorbing it, not just process optimization and, people. So it's a encompassing of the entire chain, what you described. With proper secure measures and also having a proper success criteria or a measurement criteria. So it was very comprehensive across the digital transformation. Good to know that. Now, from the individual experiences from your stint at Bosch to TVS. Per se, I know Bosch is very well known for its manufacturing excellence and Industry 4.0 leadership. How are you bringing those kind of lessons to your current company, which is TVS Electronics? And then what does manufacturing excellence look like in the EMS sector specifically?
Thank you. Thank you for that. In fact, TVS Electronics already implemented Industry 4.0 solutions in their manufacturing area. So in the EMS area, in our EMS, we build PCBA assemblies and also box build for TVSC products. Even we provide EMS service to outside of TVSC. What we have is state-of-art SMT lines with the experienced supply chain management and quality team to bring a cost-effective solutions. So what it means from Industry 4.0 solutions at our EMS is we have already implemented AI-driven defect detection systems and also MES and shop floor control systems. This will bring real-time utilization of machinery, even power, workforce efficiency, and also end-to-end traceability, right from raw material to delivery we can able to trace it. And especially when you talk about electronics, there are so many components, passive components and active components coming from different locations. Okay, so we have to bring the traceability because we are giving a warranty for our products. So this is very important from our perspective. Not only that, we have also implemented state-of-art warehouse management solutions and inventory management solutions to optimize the cost and also bring traceability of our product right from supplier to end customers. So this is already happening in our EMS factory in Tumkuru in Bangalore.
So it's good to know all the process behind the supply chain and during the supply chain kind of gets integrated, not just with the processes, but also with the people in mind. And that's something naturally you're bringing down your learnings from manufacturing excellence to this particular sector. And good to know that you are already touching the three different strategic areas of your functions. Now, in general, how does it look like in the scheme of India's EMS sector and semiconductor opportunity? As you know, India is positioning itself as a major player in EMS and semiconductors. From your perspective, what's the India's real competitive advantage? And not like kind of I too want to be in that market, but what's India's real competitive advantage that you see, and what are all the barriers that you think that is currently that we should overcome?
That's a very good question. We look at as a country, India. So we ourselves very good consumption of electronics. So we need not depend on exports. So our internal consumption itself very high. So we need to have a lot of electronics and also other gadgets manufacturers in India. So this demand, in fact, bringing a lot of manufacturers to start investing in India. Okay, it is not even the existing in the companies. They are also scaling up to meet the demand. Just a simple example, our UPI transactions, if you see, this is very high. So India is becoming a digital economy, already became, and more digital transactions happening. Okay, so that itself, mobile, if you talk about mobile, the demand for mobile, I'm just giving a very layman example, but these two give an idea for us. Okay, so where we stand as India from the digital side. Other thing, of course, talent. Okay, not only in IT, even in engineering. Okay, we have good talent pool. Already many established companies, they have chip designs, embedded software, and embedded hardware design at chip level and SoC level. So we have so many companies. Okay, so you name any electronic company, they have a design office. Already we have this talent available, and it's only a matter of going from chip to the system level. Third, of course, all of us know we have a government of India push. And of course, state governments also pushing it. PLI scheme. Okay, so this PLI scheme also kind of bringing the manufacturers or even the companies to get into the electronic manufacturing. Many state governments additionally they are giving incentives. Okay, if they start, maybe they need not pay power or the reduced power cost and also very less cost for the land. There are so many incentives they are giving it. So the policy push is also helping our manufacturers in India. Even if you look at many of the companies, like they started OSAT in most of them in Gujarat, either independently or along with foreign companies. Okay, so the idea is okay, so we are poised for growth in semiconductors. Then, of course, we faced a problem of not only we, even most of the countries in the world faced China. Okay, so there are a lot of restriction on China export on the electronics. Then everyone is looking at, can I look at Other than China, any other country can support me in the electronic side, okay, with quality and also with political stability as well. So this is also giving an advantage for India. Okay, so these are the advantages I could say. Of course, it comes with few barriers. One thing is we are kind of expert now in assembling PCBAs or making a box, but for manufacturing individual components, it can be passive components or chipped. Okay, so of course there are few startups already working make in India chips. We are also working with them, but it takes time and also the equipments to manufacture the chip. Okay, so we are getting imported, but we need to bring this in India to bring the competitive edge. Then other thing is, of course, we have to bring the cost. So the our if you look at our India as a country, okay, so we spend a lot of time on the logistics because we are not have a optimized logistics routes, or we are spending more on capital. Okay, so because we are importing most of the things, once we start manufacturing it in India, then things will improve. So that is my take.
Good to know that the market is poised good enough for us, even the local market, as you said, and then with policy decisions and government support, with few barriers that we would cross through, it's going to be an excellent ride. Good to know that. So we'll go a little fast paced with we see the EMS side of story, right? And we also see parallelly the semiconductor push that is coming through and the convergence of both. How do you think AI is transforming both the sector, and how do you see these trends intersecting? What is the commonality that we could take advantage?
Of course, AI has playing an accelerator role on both sides. One is it is driving the demand for semiconductor. Okay, so of course, all of you are aware that recently we have a big crisis on the memory and also SSD. Okay, so the prices has gone up like anything. Okay, so because of AI. Okay, so the demand coming from AI companies, we are not able to get the memories or SSDs or CPUs, okay, in a given time at the whatever cost we originally planned. Now it has gone very high.
Yeah.
Okay, so that as a positive side, yes, AI is driving the demand for advanced chips. And also other side, if I look at AI is helping the manufacturing companies, even the design side, to optimize the designs and also optimize the manufacturing efficiencies and also faster ramp ups. Okay, see, be it a quality or taking decisions, even the supply chain. Also, all these things are possible with AI one side. The other side, whatever we learned, okay, if you see the natural progression happening, EMS companies are moving slowly into semiconductor assembly. The reason is they have already mastered a box build or PCBA. So the next level is system integration and packaging at the chip level. So this is already happening. So we can see the trend at least every week. There's one company announcing, okay, so they are getting into semiconductors. Mostly they are from EMS background.
That's good to know.
So yeah.
So the thing is that as I could perceive is that definitely the demand side of things is also putting a challenge. And as the classic thing goes, let's not drop the crisis, go waste. That's a very good way of looking at it. Now, a few more questions I'll pick on your brains, particularly around the leveraging part of Gen AI. The possibilities are something that you described, right? There's so much potential. There's crisis waiting to be solved. Gen AI can perfectly fit in the engineering, and organizations need to be ready. But what does an AI ready engineering organization look like the ideal state, and what capabilities and mindsets are required for building an AI ready organization, particularly around the engineering organization?
Wonderful question. As I mentioned earlier, so AI is based on the data. So we need to have a connected systems and data flowing from end to end. That is where the engineering see a pure value. So we need to have everything is digitized. Still, I am seeing few of the things are not digitized, be it drawing in few cases, the older drawings or even the manuals. Many things are still in a paper form. We should have a digitized, connected, and of course, some governance. So we need to have that kind of infra for engineering organization to use the AI. Second, of course, we can look at the mindset of people. Okay, people should think. Okay, so everything is in my mind. Instead, they should also transfer those knowledge to the systems. Okay, so that the decision making would be much better, and we can do the faster iterations, and they can focus on architecture level instead of doing the small activities, small design changes. Okay, so they can look for architecture level complex problem solving. Okay, so there's a mindset change, so they should also understand the value chain from this perspective. Other is we can use AI end to end, right from requirement to testing with automated workflows. Okay, so currently again, silo systems, we want to automate everything. Of course, with human intervention, okay, wherever decision to be taken, we should look at AI with human.
It's good to know that when we are building an AI ready organization, what kind of infrastructure in terms of the data and what are all the silos that we need to break, as well as the mindset of people that it needs to carry. Well said there. And a few more questions in the interest of time is that definitely having gone through three different companies and three different functions and the journey, what does future of manufacturing look like for you, and how Gen AI, particularly the semiconductor and the global supply chain dynamics, reshape the industry?
Going to be very, very interesting and exciting future. Specifically, we will have a smart factories where we can look at preventive maintenance and efficiency improvement and AI assisted design. Okay, it is not going to be AI driven, it's AI assisted design and manufacture going to be there. And semiconductors going to play a very important role in the overall India growth. Okay, with the design and assembly and advanced packaging going to happen in India. So this will reduces our dependence on imports and also bring high value products from India. So this will also kind of help our domestic market growth and also the new product coming to India for world. Okay, so we can also export. It is not just import, so we can also export components to outside.
So, like, interestingly, it goes, it's not yet another chip manufacturer or alternative to China, but doing it in India for the world. That's your vision for the next 5 to 10 years, how you see this growing. So, finally, I would like to ask you a question about, after leading Bosch and Honeywell, you chose to come to TVS Electronics. What's your vision for TVS, and what kind of problems are you more excited to solve?
Yeah, thanks for that. So in TVS Electronics, okay, so the main motive is make in India and solve India specific problems, which is not understandable by others. Okay, so be it banking issues. Okay, so when we talk Aadhaar authentication. Okay, so people outside of India may not be aware of it. Okay, and even the retail. Okay, so we look for specific things. Okay, so we not only look at cost, we look at the different features. Okay, so where it is getting manufactured, what kind of content it has. Okay, so we are becoming very healthy awareness country. So we look for different aspects that should be available on the click of the button. So that is what we are looking for. So we try to bring the products to address this kind of solutions, make everyday transactions of India. Okay, so be it retail or manufacturing, logistics, banking, available to everyone at the click of the button and at the cost effective way with Make in India. So that is our aim. And we are innovating in this process, applying all the latest technologies. And of course, we also look for partners to work with in this process.
So, in simple terms, I would say for every use case, be it the health of the economy or the health of the individual, wherever EMS and semiconductor is there, you have an exciting problem to solve, and which is not easily understood by the other countries. And you want to make sure you make that difference. That's good to know. So, finally, Vijay, thank you for sharing your insights on Gen AI, digital transformation, and the larger India's manufacturing opportunity. For our listeners, you can connect with Vijay Kumar on LinkedIn to follow his perspective on manufacturing innovation and digital transformation. Thank you all for listening. We'll be back soon with more insights from industry leader. Thank you, Vijay. Thanks
Thank
once
you,
again.
Satya, for your time and interesting questions.